Okay, we are going to do this lab. What I'll do is I'll do first. You just listen only. I'll do once, and then I'll give you the packet tracer file so that you can also use that same file and verify. Okay, so the purpose of this lab is we are going to see the MAC table on the Cisco iOS switch first, and then the routing table on the router. We have already seen a routing table on the router. You have done a lab, and I have verified it. But we did not include switch. Did I include switch? So we have switch and router here. We can check the MAC table in the switch, and on the router, we can check the MAC addresses of the routed port, and also the routing table of the router. Listen, every port in the router have MAC address. Every port will have a unique MAC address. Let me show you that first. What is the command to see the interface status? What is the command to check whether the interface has got IP address, whether it is up or down? Show IP interface brief. Okay, show IP. So we have these two IP address on the router. But what is the MAC address of this interface? How do we know that? This is the command. Show, don't put IP, just type interface G000. I'm trying to show the MAC address of this particular port, this particular interface. Sometimes I use the word interface, sometimes I use the name port, both are same. Now you see, you can see the burnt in address. What is BIA? Burnt in address, which is also called as MAC address. This is the MAC address of this port G000. Let me put it on the screen. Okay, next, I'm going to show you another MAC address because I got another port on the same router. Show interface G001 this time, the last number 1. And this is the address. I copy and I paste it so that you can compare and see both are not same. Are they same? No. See, the last number is 2. It's not the same MAC address. And to see the IP address, we type show IP interface brief. To see the routing table, what command we type to see the routing table? Right, show IP route. We can see that these two networks, 10 and 20, are connected. What does that C stands for? Connected. Or connected to these G000 and G001 port. And the interface locally on that port is 3, 10.0.0.3, 20.0.0.3. It's the same interface, but this is only showing the network. This shows the exact IP address. This is the address we gave with this mask. Don't see this mask. This is not the right mask. This is the actual mask on the interface. But this is the actual IP address on the interface. When this is the mask, then this will be the network. Right. What is next? Next is on the switch, you can see the MAC address table. Let me show you the MAC table. I'm in the switch. Same command what you used to type in router, you will type in switch. Type enable and then show MAC address table. Look at this. As of now, I have only one MAC address. The MAC address of the device that is connected to F03. Let's see which one is F03 connected. Okay, the router. F03 is connected to the router. But these two device MAC addresses are not showing here. Usually, you might have learned in the beginning, switches learn MAC address. Correct. That's how it has got more collision to make. It knows who is connected where. But this switch don't have MAC address of those two computers. The reason for that is, so far these computers never communicated to anyone. Only when they communicate, the packet goes to the switch, which can learn the MAC address. Then you may ask how the MAC address of the router is learned. You see, this is the MAC address of the router, 1301. 1301. It is because the routers will send periodically a special ping message, keep alive message. That is why. You can also see that here on this switch. Go to switch 2 and check. Let me give the host name first. Both are having same name. So I'll call this as switch 2. The previous one as switch 1. That will avoid confusion. Switch 1. Okay. On switch 1, we saw the MAC address of the router. On switch 2, I'm going to show you the MAC address of the router. Show MAC address table. Note down, this is the command. You also see this. You will also see this command in the lab guide. Look at this, 1302. It's the MAC address of the other interface on the router, 1302. Now, the switches don't learn MAC address of the PC dynamically. The PCs need to generate some traffic, only then switches can learn it dynamically. Switches will learn dynamically, but traffic should come. So I'm going to generate some traffic from this PC. I'm going to ping 20002. So these packets will go now to the switch, which will learn the MAC address of this guy. All right. Likewise, I'll ping from here 20001. Okay. Now I'll also ping 10002. Okay. Now what would have happened is the MAC table would have got updated. I would like to show you, but before that, let us learn how they might have learned. You see, when I ping from here, this PC's MAC address is learned on F01. And the packet was going to the router. The router was routing the packet to this PC first. So the MAC address, when the reply comes, the MAC address of this PC is learned here. I also pinged from here to here. So when this MAC address, when this PC replies, the MAC address learned here. Already this MAC address is here. Already this MAC address is learned here. And now when I was pinging this PC was responding back. So the MAC address of this is also learned. Now if I go to these switches, I should see 3 MAC address on each. Let's go check. On switch A, show MAC address table. Look at this, 3 MAC address. Now, this is the MAC address of the first PC. How do we know? Let's go verify. F01 is connected to this first PC. Let's go verify the MAC address here. ipconfig /all. This is the MAC address. I'll copy. And I'll put it here on the screen for your reference. Now, let's go and verify on the switch. Switch, what is the MAC address on F01? Look at this, it's exactly the same MAC address. Only the uppercase and lowercase is the difference. You see? So these 3 MAC addresses are already learned on the switch. Switches learn MAC address dynamically when packet approaches. When packet approaches, switches learn the source MAC address from the layer 2 source field. See, in the data link layer, we have source MAC address and destination MAC address. What is data link layer in OSI? It's a layer 2. We have 2 MAC address, source MAC address and destination MAC address. Switches learn the source MAC address. Okay, let's also go check here. Earlier we had only 1 MAC address, but now I have 3 MAC address. Let us see the MAC address of the device connected on F02. The MAC address of this device should be this one, F02. We'll check it. I copied this from the router. Sorry, I copied this from the switch. All right, F02, right? F02. Yeah, I copied from the switch, but we will just compare now with the PC itself. Check whether the PC got that MAC address. ipconfig space /all will show the MAC address. Yes, it is. All right. Okay, that is the entire exercise. This exercise 11 is what we did. Only the difference is the topology. In this 4 router, they already have the IP address. And this port is down, so you don't need to worry. The first thing what they do is, in this lab, they go to each router and check the IP interface brief command. See, show IP interface brief command. There is one IP address assigned. Likewise, they check it on all other routers. And then I showed you the MAC table on the router interface. Yeah, and this is the command. Show interface G00. It shows the burnt in address. You remember I copied and pasted. So here we are in this lab guide, they are doing for each router. And then they are trying to ping, the ping was happening. And then after pinging, go to the switch and check the command show MAC address table. Dynamic is an optional command. I did not use dynamic. Your wish, you can use dynamic. Let's use dynamic once. I did not use dynamic, but still it shows only the dynamically learned. Right now, what happened? Only 1 MAC address. See, the MAC table get refreshed. Yeah, it get refreshed if there is no communication. If there is no communication, MAC address will be erased after 60 seconds. In the real device, it will be like 5 minutes, after 5 minutes. Okay, now if you want to know if you want to see the MAC address again, then you need to generate traffic again. Let me go to this this PC this time and try pinging 20.0.0.1 and 2 10.0.0.1. See, I use the up arrow button to get the previous configuration. See, if I want to, I don't need to type every time. Just use the up arrow and do the alteration and use it. Why every time you ping? Sorry, every time you type. Okay, now I should see all three MAC address. And I use the dynamic keyword this time, but even without dynamic, when you type, you get the same thing. That's why I don't use dynamic. Here, they're using the word dynamic, your wish. Okay. And if you want to refresh the route table manually, MAC table manually, this is the command, clear MAC address table dynamic. Let's do and see. Clear MAC address table dynamic. Now check the MAC table. You will not find any MAC address. But when some packet comes, it will come again. When router comes, router will send a ping packet every 60 seconds. So let's wait. We should be learning a MAC address on one of the port where we connect the router. That will happen in 60 seconds. No problem. Let's generate some traffic and then see. Sometimes, in simulators, you won't get that accurate result all the time. Okay. Now I should be seeing all three MAC address. All right. So we learned even to clear the MAC table. Okay. All right. The routing table, you remember we use show IP route command. Right. You can check it on all the routers. In our case, we have only one router. But in this topology of the lab guide, they have 4 routers. In this topology, you have 4 routers. And the IP address on this port, you will find by clicking this link, it should download, but it won't download. The database is no more available. We have to create this topology. And the IP address is shown here very clearly. On router 1, it is 10.10.10.1. On router 2, 10.10.10.2. Router 3, 10.10.10.3. So you can also simulate your own topology with these inputs. Okay. So if possible, if you're interested, you can do this lab. And you see they have /24. They have submitted, not /8 for 10. They have 24. All right. So at least in our topology, you try using these commands and verify. What are the commands on router? Show show interface. Well, first you type this show IP interface brief command, and then show IP route command, and then show interface G000 command, where you can see the MAC address of the port What else on the routing table router we did? Only these three commands after giving IP address. Okay, so in the router it is done. On the switch, we type show MAC address table dynamic. This dynamic is an optional one. Okay. Any other command we used? Okay, the clear command. All right, clear MAC address table. That's to refresh the MAC table. All right, so do this lab later. All right, because I have shown you now, don't do immediately. Do it later. Okay, let me give you a screenshot. So the next topic here is DNS, domain name server. What is domain name server? See, if you type in the browser www.yahoo.com, this is what called as domain, Yahoo domain. Yahoo domain you want to go. Yahoo has got a big web server. Yahoo is a web server. It's a web server. Anyone can see the web page of Yahoo. Sometime you will say www.youtube.com. That is another domain. See, when you type Yahoo or YouTube, immediately the web page comes. But if you want to see my laptop, can you see it so easily? Unless I show you, you can't see. But how do you see Yahoo's web page? Yahoo's storage, Google storage, or how do you access YouTube? It's not from your computer. You know me, but you are not able to see what is inside my laptop without me showing. But you are able to see the videos of YouTube, the web portal of Yahoo. Sometimes you also use Yahoo Mail, Yahoo News, Yahoo Sports. How is that possible? It is possible through this DNS, domain name server. This domain name server provides a service of resolving this domain name into an IP address. See, Yahoo's IP address and YouTube IP address, you don't know. But still you are able to access them. You don't know my laptop, that's why you are not accessing. Same way, you don't know Yahoo's IP address also, but still you do access. You access YouTube, but you don't know the IP address of YouTube. Same like you don't know the IP address of my laptop. See, if I want to share my laptop to the entire world, I will also register a domain name www.aaronjc@gmail.com. Sorry, aaronjc.com. Then if anyone types www.aaronjc.com, they will be able to see my laptop. But I'm not interested in sharing my laptop, so I don't have a domain name. Yahoo want to share, YouTube want to share, they have a domain name. But in the internet, to communicate, your domain name is not the real ID of a device. Is domain name my ID? No. My laptop's ID is the IP address of my laptop. My laptop, let's say this is my laptop, or this is a server, let's say it's a very big server, which I would like to share with the public. And it has got an IP address, let's say 20.1.1. It has got an IP. But we don't give IP to public. So what we do is we give the domain name. So we have a domain name assigned to my computer, www.ajc.com. Why I have this domain name? So that I can give this domain name. This domain name and this IP is mapped. If anyone types www.ajc.com, I want the traffic to come to this address. So here you are in the internet. You open your browser and you type this one, like www.ajc.com. So your computer shows my web page. How? How is ajc.com is understood as 2111 to your PC? See, if someone gives IP address, it is difficult to remember. But if someone gives yahoo.com, youtube.com, ajc.com, easy to remember. That's why we have a domain name. We have given the domain name to everyone in the world. But when you type www.ajc.com, actually the network has to take the packet to this destination 2111. But without knowing the IP address, how can your PC generate a packet to the destination 2111? Your PC may be in some address, let's say 80.1.101. When you type www.ajc.com, your PC should put this destination address. Only then the packet will come here with a port number 80 requesting for the web page. Forget about port number. Now we are trying to understand how my PC can know, how my PC knows the IP address of every domain in the earth. You go to your computer browser, you type anything, www, it will open a page. Your computer might have been purchased 5 years back. Today I have launched this web page. Today. How your 5 years old laptop knows my IP address and this my domain name, which is just created today? Not possible, right? So it is not saved in your laptop. Yahoo's IP address, YouTube's IP address, is it saved in your laptop? No, it's not possible. Why? Every time they change the IP address also. You see, today I have 20001, but when that server goes down, I will have another redundant server 20002 for the same ajc.com. So knowing a server, knowing a domain with the IP address is not Good. If you know the name of the domain, that is enough. For us, but for the system, for the computer needs to know the IP address of the domain. From where it will know? From DNS server. What is DNS server? It's a big library which is in the internet cloud that has got all the domain name and their IP address. It's like a contact list in your cell phone. I don't remember none of your IP, none of your phone number. But still, I can make a call to you because I have saved with your name your number. So every time I don't need to recall your number, I need to only recall your name. When I go to the contact list and press your name, the call goes. How? My cell phone has got the mapping. For this name, this is the phone number. Likewise. This has got for AJC, for ajc.com, 20.1.1.1. For yahoo.com, 60.1.1.1 example. Huh? It maintains this library. It maintains this mapping. So, whenever we go to a browser and type www some domain name, the PC will go to the DNS server. It will go to the DNS server, which means the PC should be configured with a DNS. Yes, there is a global DNS called 8.8.8.8. We have to give the DNS number. That's the IP address of the server, which is in the internet cloud. So when the PC do not know the address of the domain, it will go to the DNS server, query for the address. It will go to DNS server and say, hey, who is that? AJC. Oh, that man, he's 2111. Okay, then now to 2111, it makes a request. After knowing the address of ajc.com, your laptop will make a request. This is the use of DNS.com. See, if the DNS server, if you don't have a DNS server, then everyone in the world need to maintain all the domain names and their IP address, which is not possible. Because every time someone launches new web page, new domain name, every time someone keeps changing the IP address of the domain name, so it is better to have something like this, DNS. So DNS will be keep on updated for every change. If I change the IP address here to 3, DNS will know because I'll be updating to DNS. So the internet public people need to know only the domain name, www.ajc.com. They don't need to worry about the IP address. The computer will come to DNS server, get the IP address, and then use it to reach. And DNS uses UDP 53. Port number for DNS is 53. User datagram protocol 53. That's DNS. But what about ARP? Let's learn something on address resolution protocol, ARP. Address resolution protocol. You see, I have a MAC address for this PC AAA. And I have another PC with MAC address BBB. Now, our PC also got IP address 10.0.0.1, 10.0.0.2. Listen carefully. I'm going to this PC to ping 10.0.0.2. Tell me what will be the source IP address and destination IP address. When you ping from here to here, what will be the source IP address? What will be the destination? Right. Now, what will be the source MAC address? What will be the destination MAC address? Don't know. Oh, you don't know. See, this AAA is on your PC, you know it. This address you ping, so you know it. This address is your own, you know it. How this PC knows the MAC address of the next PC? Don't know, right? When you ping, it knows the destination IP, but you're not mentioning any MAC address while pinging. So knowing the destination MAC address is not possible without ARP. That is why ARP is there, Address Resolution Protocol. What it resolves, it will go and send a layer 2 broadcast packet. Layer 2. What is layer 2 broadcast? Say, for example, if I have a switch and I connect in many computers, this packet that this A is sending will go to everyone because it is sending to a layer 2 broadcast. Layer 2 broadcast is F, 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 12 times F. All the bits are on, that is broadcast, right? This is layer 2 broadcast. MAC address is how many bit size? 48 bit size. So all 12F. This is what called as layer 2 broadcast address. So ARP will use this address and send a broadcast. And it will go to this PC, and this PC. Only this PC will say, I am 10.0.0.2 because this, what is this ARP is requesting? In the ARP request, it is asking who is 10.0.0.2. It's literally asking who is 10.0.0.2. This guy is 10.0.0.3, so he won't respond. This guy is 10.0.0.4, he won't respond. Only this guy is responding. When this responds, what will be the source IP? 10.0.0.2. What will be the destination IP? It is responding to the sender. Sender is 10.0.0.1. What will be the source MAC address? Its own MAC address. To whom it is responding? The sender. Sender was sending from AAA. So it is sending. This is what called as ARP reply. ARP request was a layer 2 broadcast. But ARP reply is a unicast. When this response go, when the ARP reply go, PCA will learn the MAC address of B. Now it puts that MAC address, which it has learned, in the ARP table. The command to see the ARP table is ARP-A in Windows computer. ARP-A. ARP space -A. You go to your command prompt and check. You see, but after learning the MAC address, only this ping will be successful. That is why sometime, when you ping, the first 1 or 2 packet is missing. You remember when you did the lab, you might have seen 1 or 2 packet missing. It is because it takes some time for the ARP to learn the MAC address and give you. By the time your ping packet is getting timed out. You understood ARP? It learns the MAC address. Okay, now going back to this lab. Lab number 12 is about configuring DNS on the Cisco router and an ARP cache. All right, I'll do and show you this lab in our next class. Right now we are just going through this. Now, this is how you configure a router to be a DNS server, right? Domain lookup means what? Look into the domain name so that you can resolve, right? Checking the reachability between the routers. You see, here he is not pinging with the IP. He's pinging with the domain name. Ping R2 means what? It is pinging the IP address of R2. We learned this one. We'll do the lab and learn this one in our next class. You need to do only this previous lab, lab number 11. You don't need to build this topology. You can do with your existing topology which you did homework. All right. Okay. Fine then.